In this video, I'm going to be performing partial fraction decomposition involving an irreducible quadratic factor using the method of comparing coefficients. So for this example, I'm going to be decomposing x plus 3 over x squared plus 2, x minus 1. The first step is to assume the partial fraction form. You can use the table to help write this as a partial fraction. So first of all, the linear factor x minus 1 gives us a over x minus 1. The irreducible quadratic factor gives us bx plus c over x squared plus 2, because the top and the bottom of the fraction can only differ by a power of 1. The next step is to multiply through by the left-hand side denominator, so multiplying everything by x squared plus 2 and x minus 1. And we can cancel out some of the terms. This leaves us with x plus 3 is equal to a times x squared plus 2 plus bx plus c times by x minus 1. Expanding the brackets and collecting the like terms, this gives us the equation x plus 3 equals x squared times a plus b plus x times minus b plus c plus 2a minus c. So comparing the coefficients to get the simultaneous equations, we start by comparing the coefficients of the x squareds. On the left hand side we have 0x squared because there is no x squared term, and this is equal to the x squared times a plus b. Therefore 0 is equal to a plus b. Next, comparing the coefficients of x, this gives us that 1 is equal to the minus b plus c. And then finally the numbers, 3 is equal to 2a minus c. And you can use any method that you know for solving 3 simultaneous equations in 3 unknowns. So here I'm going to start by rearranging that first equation to get the substitution a equals to minus b. So I'm going to substitute a is equal to minus b in that second equation, and then leaving the third equation as it is. From here, using elimination, so the second equation has plus c, the third equation has minus c. If I add these together, I get that 4 is equal to 3a. So dividing by the 3, I get that a is equal to 4 over 3. I can now put this into that top equation, that a equals minus b, and this gives me that b is equal to minus 4 over 3. And then finally, choosing one of the other equations to substitute this into. So for example, 1 equals minus b plus c, therefore c is equal to 1 plus b, and this gives me that c is equal to minus 1/3. Now I have the values for a, b and c. I can put these back into our assumed partial fraction form. This gives me x plus 3 over x squared plus 2, x minus 1 is equal to 4/3 over x minus 1 plus minus 4/3 x minus 1/3 all over x squared plus 2